Hello guys, with this video I explain main steps of deployment of artificial intelligence project where backend is Keras with Flask and the front end is web application. This application analyzes a given X-ray of human lungs and returns a diagnosis to the user. I do not explain here all technical details, for example how I build neural networks and why I use specific architecture of the network. Here I demonstrate the idea of roadmap, how a simple Python project on Jupyter Notebook transformed into real-world application that even looking nice and user-friendly in mobile devices. So in this part you see the very beginning of the project. From this part I began the project from zero, and in Jupyter Notebook I created a convolutional neural network architecture. I created a data preprocessing engine, and I made first test to be sure that my model is working. So let's begin from the top, and as you can see, as usual, I imported all necessary libraries and modules. It is Keras, it is standard Python's models, it's NumPy, Pandas, of course Matplotlib for visualization purpose, and what I have to highlight is my custom model. As you can see here, it helps us to restructure data. If you have data provided not in very good structure, my custom model make restructuring data to test, train and validation, and inside each folder you see different classes, is bacteria, normal and virus. For this I created my custom model which do the stuff. Of course you should know some rules, how to recognize which classes belong to each folder, how to assign classes to full system. It depends on your tasks. In some cases you need this kind of more custom code, in some cases no. If you download data from Kaggle, so often Kaggle provide very good structured raw data, but I decided to go in hard way and to write my own model to structure data as I want to be sure that my model will load data very correctly. So come back to Jupyter Notebook, and next cell is some description about the data, and what I have to tell to you is, for training purpose I trained more than 4,000 images. It's about 1.2 gigabytes of data. Okay, what I have to say in this part is, for loading data I used a Keras generator. Why? Because it recognizes class names from folder name. For example, if you have bacteria or normal or virus in test set, it automatically recognizes, okay, this image is for bacteria, these images are for normal, and these images is for virus. Okay. Okay, I visualized some random data to be sure that my data read correctly. Is 5,000 images belong to class number 3, 600 images belonging to class number 3, and 16 images belonging to class number 2. So that's internal check-in. that to be sure that I go in the good way. So, and the next very important part in this stage is to build convolutional neural network architecture. So this part was, I think, the most complicated for me, because I made I made multiple variation. I made multiple architectures for this task, and as you can see right now, is one of these. One architecture it returned bad results. One architecture uh, caused gradient vanishing problems, and as you can see right now, it returns quite good accuracy. Is about 80 or 85%. And just some summarized data and training process. I set 100 epochs, and as you can see from graphs, I think it is enough, and because as you can see, the score for validation and training sets is achieved 85%. For validation is about 75%. When loss score is going down, and at iteration number 100 it reach only two. That's really small number of losses. So okay, of course I could make 500, even 1000 epochs, and my model should be even better, but okay, for this time I set 100. So next thing what I have to tell you is to, after each training process, I save all the data to my computer by using these commands. And as you can see, for example, on this day I made 3 experiments, and as you can see, I saved all the data for this experiment. It is a plots, it is a architecture, weights, and all available data from Keras in this session. Okay, and after this, if you feel happy about your model, you should load the model as from separate files. So you should load architecture, you should load weights, and try to predict a random image from pre-trained model. And okay, this is an example. I loaded a I loaded a random image from my validation set, and okay, we think this is a virus, this is a prediction, and I know this is working. So if I'm happy with my model, that is all for Jupyter Notebook, and go to the next part. Okay, in this part I show how I deployed my model, and I created deploy folder, and in this deploy folder you need to create your Flask application, and my Flask application goes first on app.py. And what this Python file is doing, it is a Flask application, and I imported a Flask module and the stuff. And what this application is doing, first of all, it's load architecture file from JSON, which was saved in Jupyter Notebook, as you can see here. It loads weights from H5 file, which is also saved from Jupyter Notebook from Keras, as like this. And it's connect architecture and connects weights, and when connect it make a full model, and it is the same as you make this all training process. Let's imagine that you have pre-trained model loaded from your directory. So it's very good, it's very efficient way how to deploy your model. And next step in my Flask application is to make a prediction, and it is the same as I simulated in my Jupyter Notebook. Remember when I loaded my model from weights and from architecture, I could make a prediction. This is a virus. And I did the same, but in shorter way in my Flask application. I just one difference. If I load a random image in this way, let's say image open directory to my image, here I make upload function that let you to upload your any image from your computer and make a prediction after. It is I know this is not very simple, but if you try to build your very simple application, I guess that you can to move to more advanced coding in Flask very shortly. So this is upload directory. This is a 4 images that I uploaded in my application. This is my JavaScripts. Which make your front end more user friendly and more readable. Also CNN, it's rules for style, like background color, like margin, paddings, colors, all the stuff related to front end. And template, it is an index. What index is doing? Index get the data, gets the information from your application written in Python. So, and it get this information to front end. It is a result. It is a okay. It is a, let's say, file, you see image upload, it get the data from your Flask application, and base.html it's load additional JavaScript from bootstraps, from some custom JavaScript libraries, and this is a JavaScript files written by myself in here. So it is like a web development part while deploying a Flask application, and if you want to can create a very user-friendly web application by involving HTML, CSS and JavaScript. But the most important to understand what is under the hood in here, how to transform your Jupyter Notebook to Flask application, and you need to write app root and directory and methods for each procedures. For example, if I want to upload, it is a directory where I need to upload my images. It is uploads. It is a method, it's a get and post, because I upload and after from get I make a predictions. And just before going to the next part, let's try to deploy our application on our local computer. So first of all, I run terminal which load my deployment environment. You see all the files for deployment are here, and the most important is application.py, which, as it always telling that it is the engine and this is the heart of what we want to deploy. And remember, it is index, upload function, prediction function, yes, and this is the Flask. This is the most important part. It's loading weights and doing all the backend stuff, and all the magic is happening here. And don't forget to make debug equal true, because if something happens, any errors, any warnings, you can track it. So let's try it. Let's try to deploy. So Python and app.py. Just wait for a second. Okay, so it's working. TensorFlow is loaded, and yes, I have my address on localhost. I just copy it and go and try. Okay, it's working. Go to network, try to upload any random photos, and okay, no errors. Yes, and make a prediction, it's normal, no errors here. Let's try different. No errors, prediction, very good. So go to the next part, and that's all for this one. Okay, so in this part I want to deploy my Flask application in the server, and for this I choose Google Cloud because of its simplicity and prices and user-friendly interface and controlling engine. So let's go to Google Cloud Console, press here, and so I have created the project dedicated to my application. It is a Flask deploy. This is the ID, and first thing what you have to do is to activate the Google Cloud Shell by pressing here, and just wait for a second. Okay, you have to be sure that it is your project, and if it's correct, so press this button. It is editor. Launch your editor. Okay, wait for a second, and you see this is files and folders and directories directly imported from my deploy folder. You see, this is my deploy folder, and the same files are here, almost the same. What you have to make additional, it's your EML file, which tells the server how the application should work, on which configuration, on which framework, on which runtime. In my case is Python, environment is flexible, entry point is unicorn. I want to deploy application that name is main. Python version is free, and of course you need to create your requirement.txt file, and it is not should be so big as you can see right now, because I didn't create a local environment, and I created this list manually. I think I need to delete some rows, but okay, it's working, and you know, I feel so good with these requirements, and it still works. And okay, if you are sure that it is all stuff the same as you have here, you should go to App Engine, go to Settings, and enable application. Okay, I enable my application. Just wait for the second, because when you enable your application, you can deploy your application from editor. If you disable, automatically your deployment stops, and for this we need to wait when the server let us to deploy our application, and for this I click on enable application. So I need to wait for a little bit, and this is the address where my application will be available. I can copy and try to run. You see error is 404. This is not found because it is not enabled still, and it is not deployed. So okay, it is enabled, and now I can deploy. I write gcloud app deploy. I need to change my directory to this internal folder. It is and try to deploy again. Press yes, and while the server trying to deploy your application, it is a good time to go to take a coffee or to take a break, because it usually takes about 5 minutes or 3 minutes. It depends on the complexity of your application. In my case, it can take about, I think, 5 minutes. So let's come back when deployment processes will be finished, and on the next part I will show you how to test your application on the server. So that's all for this part, and go to the next step. Okay, it seems that my application is being deployed on Google Cloud, and there's no errors and no warnings, and in your case you should see very similar output in Google Cloud Shell at the bottom of the window. And let's try to see if our application is successfully deployed. Just copy this address, or maybe go to this one, and remember, when our application was disabled, we got a error 404. It is not found error, and let's try to refresh it. After refresh the window, we see that application is running. Okay, let's inspect the full process that is happening behind. Okay, let's try to upload any random image, open, and try to predict the diagnosis. Just waiting for a second, hoping that no any errors will happen. Okay, it's normal, no errors, it's working. Let's try another one. No errors, working. Okay, and the final one. Okay, let's try this one and predict. Okay, it's working well, and that means that our application is working. And that's all for this part. Okay, when we tested our application on the server, now we can to share our app link to any user that you want that he use your application. Let's try to do it. Let's simulate that you share your link to another browser. Let's try. Yes, it's also working. Let's import any photos. Okay, it's virus. Next important thing is let's try your application on mobile device, and let's see how it's working on your mobile phone. Let's see it.